Okay, let's start with 29. They want to find the difference quotient and tell me what that is. So let's go through it one step at a time and make sure I get the pen out. So the difference quotient, f of x plus h minus f of x divided by h. Well, let's put this down. So f of x plus h is going to be x plus h squared minus 2 times x plus h plus 3. Then you're going to subtract away the function, so minus x squared minus the minus 2x is plus 2x, and then minus 3 all over h. All right, I got to do some simplifications over here. The top is x squared plus 2xh plus h squared minus 2x minus 2h plus 3 minus x squared plus 2x minus 3 over h. I see some things disappearing. For example, the x squared's gone, the 2x is gone, and the 3 is gone. Now I'm going to divide through by h. And what do you get? You would get 2x. Whoops, let's go back to black ink. You would get 2x. I'm dividing every term that's left on top by h, plus h, minus 2. Final answer. Let's go to the next question. Next question is multiplication. You're going to be taking the dimensions of this thing, which is, this is a 3 by 2, and this is a 2 by 3. These are matching up. I'm sorry, it's 2 by 2. The twos are matching up, and then the dimension of the final result is going to be a 3 by 2. All right, let's go through it. And again, row times column. And let's just be careful. I mean, it doesn't look that bad to do, but mistakes can happen. And let's put down the first entry, which can be minus 1 times 0, which is 0, and then 6 times minus 1, which is minus 6. That gives me minus 6. That was row 1, column 1. All right? By our result is going to be a 3 by 2. All right? Let's do the next entry. This is done. I'm going to get minus 1 times minus 2, which is 2, and then 6 times 3, which is 18, and that's going to give me 20. All right? Let's keep moving. This is done. Let's do the next one. And I'm moving on to the next row, by the way. And the next row is this one over here. All right? Let's see if we can do that. And 2 times 0 is 0. And minus 5 times minus 1 is 5. You get 5. All right? 2 times minus 2 is minus 4. Minus 5 times 3 is minus 15. And that's going to give me minus 19. Cross that out. Let's go to the last row. And let's do our multiplication. And what do you get? Minus 3 times 0 is 0. 4 times minus 1 is minus 4. That gives me minus 4. Then I get minus 3 times minus 2, which is 6. And let's take a look at that. 4 times 3 is 12. What does that give me? 18. All right, final answer right over here. All right, minus 620, first row. Second row, 5 minus 19. And then minus 4, 18. All right, let's keep moving. This one's a log problem. And let's write this down. They're log base 5. So we get 2x plus 1 times 2x minus 1, and this is log base 5, equals 2. I'm going to write it as an exponential, and that's going to be 2x plus 1 times 2x minus 1, 5 squared, which is 25. What do you get? 4x squared minus 1 equals 25. 4x squared equals 26, adding 1 to both sides. X squared would equal 26 over 4, or 13 halves. X will equal plus or minus the root of 13 halves. There is a problem over here, and I can't use the negative root because in the second term I'd have trouble immediately. There'd be a negative argument. So the only answer here is x equals the root of 13 halves. That's done. All right, let's do 32. 32 is, write the system linear equations represented by the augmented matrix. Let's write this down. And what do you get? You get 5x minus 2y plus 3z is equal to 4. Then you're going to get 3y minus 1z is equal to 6. And then you're going to get 2z is equal to minus 6. So I did that part. The next part says use back substitution to figure it out. Well, here you go. Z is minus 3. I'm going to go back into here and see what this gives me. I get 3y plus 3 is equal to 6. That means y is equal to 1, because 3 plus 3 is 6. Back substitute over here. What do you get? 5x. Let's see, minus 2y, which would be minus 2, and 3z, which would be minus 9, and that equals 4. Let's see if we can do that. Let's see, minus 2 minus 9 is minus 11. Add 11 both sides, you get 15. X would have to be 3. All right, so let me write down as a triple. X is 3, y is 1, and z is minus 3. You can also just circle these things and say that's the answer. Thank you. Let's go to the next one. This is a domain problem. There is a radical. Fortunately, x squared plus 9 is always greater than 0, so not to worry about that. What I do have to worry about is the bottom ever equal to 0. So let's write this down. X squared plus 9 equals 5. That's when it would be 0, by the way. Square both sides. You get x squared plus 9 equals 25. X squared equals, take 9 from both sides, 16. So x equals plus or minus 4. So the answer over here, the domain of this thing is all the real numbers except x plus or minus 4. If you want to write the interval notation, it's going to look like this over here. Minus infinity to minus 4, union, minus 4 to 4, union, 4 to infinity. Okay, let's keep going. Okay, this one's a composition. Pretty easy to write down, by the way. This is going to be g of f of x. Well, it's going to be g. What's f of x? It's the root of x plus 6. What does g do to it? It squares it. Well, when you square that argument, you just get x plus 6, and then it subtracts 5 from it. So what do you get over here? You get x plus 1. Fairly simple. And of course, I have a question. The second part of the question is, what's the domain of it? Well, let's take a look at it. And one thing I want to point out to you is what is f allowing in? F only allows in x greater than or equal to minus 6. All right? So what does f pump out? It really doesn't much matter because g will take any argument at all. So the domain of this thing over here is going to be x greater or equal to minus 6. If you want to write it down in interval notation, it's going to be, minus 6 off to infinity. Either answer is fine. Let me just put a box in this over here, though. All right, then move on. And this one over here, we're given a polynomial, and we're given roots of the polynomial. Well, if 2 is a root, then I know there's a factor, and that factor would be x minus 2. And if minus 3 is a root, the factor would be x plus 3. I'm going to multiply that out. You're going to get x squared. Let's see, plus 3 minus 2, which is plus x, and then minus 6. And we're going to divide this into 2x4 plus 7x cubed minus 4x squared minus 27x minus 18. And things will go smoothly. What do you get over here? Well, it's going to be 2x squared. What do you get there? 2x4 plus 2x cubed minus 12x squared. Let's do the subtraction. What do you get there? You get 5x cubed. Let's see, then you'd get plus 8x squared minus 27x minus 18 plus 5x. You're going to get 5x cubed plus 5x squared minus 30x. You're going to subtract, and you can get 3x squared let's see, plus 3x minus 18 plus 3. You're going to get 3x squared plus 3x minus 18. Well, as expected, it worked out pretty nicely. So what do they want me to do? They want to factor it. So let's write this down. F of x is equal to x minus 2, x plus 3, 2x squared plus 5x plus 3. I can continue to factor that. Let's take a look. 2x and x. And let's see. It looks like 3 and 1 plus plus. Let's just check it. You do get 2x squared. 2 and 3 is 5x. Yeah, it worked out beautifully. This is the factorization. All right? So we're given a polynomial. We're given 2 of its root. Use long division to completely factor. We completed it. All right, this is an inequality problem. We're going to get it equal compared to 0 first. So it's going to be 3x minus 2, x minus 1. I can subtract 1 from both sides, which same thing as x minus 1 over x minus 1. Common denominator is x minus 1. What goes in the numerator? 3x minus x, which is 2x. Minus 2 minus a minus 1 is going to be minus 1, and that's greater than 0. What goes in my number line? The 0 of the top, which would be 1/2. The top becomes 1/2 at 0. At the top becomes 0 at 1/2, and the bottom becomes 0 at 1. Take test points out, and a good test point would be like after 1, like, I don't know, any number, like 1 billion if you want, and it's certainly going to be positive, which satisfies it. All right? Now, we can't shade in the 1 because I have division by 0. Now, between 1/2 and 1, I'd say 3/4, if you plugged it in, you would get positive on top and a negative on the bottom. So it's negative, would not shade that in. A half gets shaded in because the top becomes 0, and that means it's equal to 0 at that point. If you go below half, like 0, plug it in, what are you going to get? Negative over negative, which is a positive. That gets shaded in. All right? What's the answer over here? Minus infinity to 1/2, inclusive, union, 1, off to infinity. All right, let's keep moving. This one, solve the system. Any method is fine. I would use an augmented matrix. And let me write that down for you. Pretty easy to do, I think. So what do you get? 1 minus 3, 3. You would get 1, 2 minus 3. You would get minus 1, minus 1, 2. Put a little line there, indicating equality. 4 minus 6, 5. All right? What I noticed immediately, and I'll write it down for you, I noticed that if I took row 2 and added it to row 3, I'd get something pretty simple. And I want to give that back to row 3. I'm going to write that down for you. And if I did that, what do you get? Let's see. I'd get 0. And then I'd get what else? Let's take a look. 2 minus 3 was minus 1. And minus 1 plus 2 is 1. And minus 6 plus 5 is minus 1. All right? So it's the first thing I did. I want to do something else now. I'm going to take that row 3. This is the second thing I want to do. Second. I'm going to take row 3, add it to row 1, and give it back to row 1. All right? And I'm looking at it, and I'm going to take the row 3. Let me just emphasize what row 3 is. This is row 3 now, and we're going to add it to row 1 and give it back to row 1. What do we get over there? We can get 1. Let's see, minus 1 plus 1 is 0. Minus 1 plus 1 is 0. And 4 minus 1 is going to be 3. All right? Now, certainly, what are you going to do now? I got to do something. And let's write this down. So we got minus 3, 2, minus 1, and minus 6. All right, let's look around for something to do. And I'm thinking to myself as, maybe the third step might be my final step. I'm going to say row 3 plus row 2 and give it to row 2. All right, let's see what happens. So first row is just 1, 0, 0, 3. The third row, 0, minus 1, 1, minus 1. Now if I did this row 3 plus row 2, I would get minus 3. I would get 1, because 2 plus minus 1 is 1. I get 0. And then I get, let's see, minus 7. All right? So I think I think I can do it now. And by that I mean x is 3. That's from the first row. That's right over here. I'm going to go to the second row now and write it down. And that's going to be, if x is 3, that's minus 9 plus y is equal to minus 7. And that means y would be equal to 2. All right, let's go to the third row and see what we get over there. And what do you get there? You would get minus y, which is minus 2, plus z, which is going to be minus 1. Well, that looks pretty easy too, by the way. That looks like z would just be the number 1. So let's write this down. My triplet, x is going to be 3, the y is going to be 2, and the z is 1. If you want, you can check it. I would say if you're on an exam, by the way, I would continue to do the exam and maybe check it later. All right, let's go to 38. And 38 is partial fraction decomposition. The first thing to do is write down that there are factors in the bottom, and that's a cubic problem. So it's going to be x minus 1. Then you're going to get x squared plus x plus 1. On top you get 4x minus 1. Well, let's break it up. What are you going to get over here? Well, let's write this down. You're going to get two denominators. One is denominator is a fraction of x minus 1, denominator, plus the other guy is x squared plus x plus 1. And this equals 4x minus 1 over x cubed minus 1. What goes here is a. Then I got bx plus c. I'm going to multiply both sides by the LCD, and you're going to get a x squared plus x plus 1 plus bx plus c times x minus 1 equals 4x minus 1. I'm going to pick an easy x, at least easy for me. X is 1. And if you do that, what do you get? Well, you get a, and you get 3. The second term disappears because if x is 1, you get a factor of 0 there. And if x is 1 on the other side, you get 4 minus 1, which is 3. Relatively simple. I now know the a is 1. All right? Let's try another one. I'm going to try x to be 0. And what would you get over there? Well, you're just going to get, a is 1, and if the x is 0, you just get 1 times 1, which is 1. And then what are you going to get? You can get plus c. Again, x is 0. If x is 0, you get minus 1 over here. And then you get minus 1 there. What is this going to give me? Let's see if we can do that. And you're going to get, let's see, minus c is equal to minus 2, where c would be equal to 2. Let's try another number. And again, you're free to choose the numbers you like. I'm going to choose, I'm going to minus 1 now. And what do you get there? Let's see, a is 1. More complicated, isn't it? And then what do you get? You would get 1 minus 1 plus 1, which is 1. Plus, again, x is minus 1, so you get minus b. C, I believe to be 2. And then what do you get? You get minus 2 here. And that would equal what? 4 times minus 1, minus 4. Minus 4 minus 1 is minus 5. Well, you're going to get 1 plus 2b minus 4 is equal to minus 5. You're going to get 2b minus 3 equals minus 5. You're going to get 2b is equal to minus, let's see, if you add 3 to both sides, minus 2. So b is minus 1. All right, so I think I'm ready to go and to write it down for you. What's a? A is 1. So what do I get? I get 1 over x minus 1. And then you can get plus, well, the b is minus 1, so it's minus x. The c is 2, plus 2 over x squared plus x plus 1. All right, let's keep going. And that's it. We got it. Thank you so much for paying attention.